Hello, welcome to my Unity tutorial on Parallax. This video assumes that you have a basic understanding of Unity and C#, but I'll try to include links to any relevant information that might help you with the more advanced stuff. Good luck and have fun. For this tutorial, I'm going to start with a new project. Go ahead and select the arrow next to New, and select the version of Unity you'd like to use. I'm going to select this one. Next, make sure that you select 2D project and name it whatever you'd like. Once you've named your project and opened it, it's time to import our sprites. You can use the ones that I'm using for this tutorial by downloading the zip file in the description to the video. Next, we'll set up our sprites. If you select them all, we're going to change the mesh type from tight to full rect. Next, we'll change the filter mode from bilinear to point, and the format from automatic to RGBA 32-bit, and then click Apply. With the sprite set up, I'm going to create a new empty object called Environment. I'm going to use this kind of like a folder in order to keep all my sprites in one tidy place. Underneath Environment, I'm going to create a child empty object. To save time, I'm going to name this Background 1. That way, I can easily duplicate it, and it will continue the naming convention. Next, I'm going to rename Background 4 to Middle Ground, and then Background 5 I can change to Foreground. Now that I've named each of my objects, I can select them all and add sprite render components to each of these game objects. If I click Add Component and start to type Sprite Renderer, it should appear in the drop-down menu. Once I see it, I can select it and it will add them all simultaneously. Next, we're going to change the draw mode from simple to tiled. This is what allows the sprites to loop. With the properties of our sprite renderer set up, it's time to add the actual sprites themselves. If I click the selector here, I can go ahead and select background 1. For background 2, I'm going to do the same, and so on. With all the sprites assigned, I'm going to go ahead and set up the tiling. The height is already set up for us, but the width needs to be adjusted. So I'm going to scale that up to a really high number, say, I don't know, 900. With that in place, we can begin setting our sprites into their proper positions on the z-axis. If we take this one and slide it back a bit, scroll up so you can see, slide it back, we're going to go to about, I don't know, 30 on the z. Next, we'll go to background 2. Then we can just slide it back here. This one we can put to 35. Lastly, we're going to do the same thing with background 3. We're going to move that to 40. Then we just need to move the middle ground to 25. I often switch back and forth when doing parallax in order to see it better. You can hit the 2D button here, or just press the 2 on the keyboard if you'd like to toggle back and forth. But with that done, I'd like to go ahead and add a player. So we'll go ahead and create an empty, and I'm just going to call this player. Make sure to go ahead and right click and reset the transform. Always proper format here. Thank you, Rick. Go to 2D object, sprites, and we're going to add a square as a child object. You can add your own player character here if you'd like, but I'm just going to use a square, and I'm going to scale it down a little bit so I can see it. Scroll that down here, and it's going to take the place of player, so it's got to be on the ground. The amazing fighting square. So, in order to find the proper camera size based off of the sprites we're using, we can use a mathematical formula. The mathematical formula is taking the height here of the sprite and dividing it by the pixels per unit. So let's open up our calculator, and then we're going to do what I said. So we're going to divide the 180 and by the pixels per unit here, which is 100. So 180 divided by 100, which is our pixels per unit. That leaves us with 1.8. Next, we take that figure and divide it by 2. And that is our proper screen size, or I'm sorry, camera size. So you go here to main camera, change the size from 5 down to 0.9, and then it will fill properly in the game window. While we're here, we can go ahead and change our clipping planes. If we change the near clipping plane to 0 and the far clipping plane to 50, it'll help us out in the future. Now, because this isn't a proper game, we don't have the camera actually moving with the player. So I'm going to do a little bit of a cheat and just drag it as a child of the player. This will ensure that when the player moves, the camera moves. Now, in order to get our player moving, we're going to need to add a script. So let's go ahead and do that. Click Add Component, type in Mover, which is the name of the script that I'm going to add. Click Create and Add, and then open up the script. With the script open, we can go ahead and set up some variables. First, I will type serialized field of type float, and I'm going to call this move speed. And I'm going to initialize it as 0.5f. Now, I don't need the start method, so I'm just going to delete it. And I'm going to go down here to the update method where we can get this thing moving. So we're just going to write transform dot position equals transform dot position plus new vector 3, and then in parentheses we're going to simply put move speed times time dot delta time, and then 0 on the y and 0 on the z. Go ahead and save that script up and transfer back over into Unity. After it compiles, you can hit play, and you'll see here that the player is moving, and if you transfer over to the game window, you can see it starting to take shape. So let's get it finished. With that done, we'll go ahead and select all of our environment objects and add a new script which we'll call Parallax. Try that again here. So, we'll need some variables, beginning with a public camera, which we will call main camera. We're also going to need another public variable of type transform, which we'll call the player. We're also going to need some variables to reference the positions of our sprites. I did this by creating a vector 2 called start position, as well as a float, which I call start z position. For the next part of our script, I'll be using properties implemented by way of expression body definitions. I'm going to attach a link to this in case you're unfamiliar. Our first property will be called travel, and it's a vector 2. And it's going to measure the distance the camera has moved from its original position. So we'll just cast it over to a vector 2 and put main camera dot transform dot position minus start position. Next, we need some point of reference in order to create the parallax factor. Do you remember how we set up our clipping planes on our camera? This is where we'll be using that. So we need a float called distance to player, which equals transform dot position dot z minus player position dot z. Now, because we have a foreground layer that actually sits in front of our player, we need our script to find the closest clipping plane, and I'm going to do that by using a ternary operator. So float clipping plane equals main camera dot transform dot position dot z plus distance to player greater than 0, and then here's where we're putting that ternary operator in. So if it's greater than 0, we'll use our far clipping plane. If not, we use the near clipping plane. Now we can define our parallax factor, which will be of type float, and it will be equal to the absolute value of the distance of the player divided by the clipping plane that we set up. So parallax factor equals mathf.abs, and we're going to pass in the distance to player do you know what it is? Divided by clipping plane. Right. Next, in start, we just have to set up some of our variables here. So we'll just put start position equals transform dot position, and then start position or start z position equals transform dot position dot z. We do this because we're working in a 2D space with 3D rules here. So rather than casting it back and forth, we can just save it as two separate variables. So in the update method, we just write vector 2 new pos, and that equals start position plus the travel times, do you know what it is? Parallax factor. And the last line, we'll add transform dot position equals new vector 3, and then we're just going to pass in the new pos dot x, new pos dot y, and then start Z position. With that done, just hit Control S to save and return back to Unity. Back in Unity, we just need to set up a few fields in our inspector of our sprites. So if we select them all here, you'll see a new field for main camera and player for our public variables. So if you hit the selector, just go ahead and select main camera. On player, go ahead and find player here as the game object. With those things done, we can go ahead and switch it to play maximize so we can see it in all its glory and hit play. With any luck, we should have yes. It's working greatly, although I do see an error here. This is a simple problem here. I think I missed a parentheses. Let me just take a look here. And yeah, there it is. So if we just put a parenthesis here, and then the other one here, that should fix our error. So let's go ahead and save that. Switch back over to Unity, hit clear our errors, hit play, and with any luck, yes. So that about wraps up my tutorial for Parallax in Unity. Thank you so much for watching, and I hope you learned something.